Okay, so this would be, now, most everyone here, I don't think anyone here is from honors geometry, right? If you're in honors geometry, sorry, you're not quite so lucky. You only get one flex day. Oh, and I should have called that Park Flex Day, not CMAS. Sorry about that. I just noticed that I have that in the schedule. Oh, actually, no. I did give honors geometry 2 days as well. Okay, so I take that back. No matter what class you're in, any geometry class, I gave you guys 2 Park Flex Days, so state testing days. So it sounds like a lot of you that are here today have testing Wednesday and Thursday. So for this week, for example, what you'd want to do, because I know some of you even possibly have it next week. So it's kind of, it just depends. Yeah, exactly, Michaela. So you have Friday and then next Monday, and I'm kind of in that same boat because I have Friday, I'll be proctoring, and then all next week I'll be out. So we'll have recordings. Just watch the announcements for that. Actually, everything's really already posted over in the Class Connect recordings area, so you can jump ahead there. There is one in April, Gabby, that's called the CMAS. So I should have, this one, it's very confusing because they keep changing the name of the test. So it's hard for me to keep up with what they're calling it. I should just call it State Testing Day. That way, whatever they call it, I'm covered. But yeah, March and May it's called Park. The one in April is called CMAS. So anyway, it's really confusing. Yes, you know, Tabitha, that's a good question. I don't think in 8th grade it should work the same. So that's the nice part this year in math, because you guys are, you know, you've done this for a while now. And so up until this year, they've always based the test you take on the grade level you're in. This year that's changing. They're going to give you the test of the class that you're in. That should be how it works. So since you guys are all in geometry, you'll be taking the geometry test, which makes sense, right? Because that's what you're going over right now. And so that's what we should be testing you on, rather than Algebra 1 that you had last year or something. Yes, so they will, yes, you guys should all be taking geometry when you get to Park, okay? Okay, yay, good, I know, exactly. So that makes you feel more confident going into the test, right? Because you feel like, oh good, I don't have to go back and review all that stuff that I forgot last year. No, you guys didn't forget anything from last year, right? You remember everything very clearly. I know, last Class Connect actually was a good point of review, right? We talked about foiling, and you guys are like, oh, yeah, I really need to go back and review that. So, anyway, for geometry, though, hopefully everything's fresh. And we'll keep going over stuff, and then in May, you'll be tested over, you know, hopefully you'll be even better in May, because we'll obviously be going over more geometry between now and then. Okay, so back to my original point. What I was saying, if you are here today, obviously you're not doing the state test, so you're going to want to rearrange the schedule. The way I put it in the announcements, it's showing that Monday and Tuesday you have a flex day. Well, you don't want to use your flex day if you guys are in this class because you're here Monday, okay? What you want to be doing today is you want to be doing lesson 3.08. And then tomorrow you want to do 3.09. Let's say you have testing starting Wednesday and Thursday. Well, then that's when you would put your flex day in there. Okay, so don't do any math Wednesday and Thursday if you have testing those 2 days. Just concentrate on your state test and do well on that, okay? Then on Friday, you shouldn't have testing. It's only 2 days this year out of the week. Okay, so then on Friday you come back and do 3.10. So basically this week you have 3 assignments in this class, and if you have 2 days of testing, there's your 5 days of math, okay? So whatever 2 days you're testing, put those flex days there. Don't worry about coming back and doing anything in this geometry course. But the days you are not testing, do those 3 days worth of assignments, 3.08 through 3.10, okay? Now, if you're not testing at all this week, but you are testing next week, what you want to do is you want to get in here, get the geometry class done, the 5 days this week, and move those flex days to the following week, okay? So the point being, by the 20th, you should have everything in Unit 3 in, including the test, Part 1 and Part 2. Okay? Hey, yeah, go for it. If you want to do that, you can do that as well. I never have a problem with you guys moving more quickly, just don't go slower, okay? Because then you run into not getting things in on time, and that's bad. Okay? Oh, cool, Ben. Oh, that's right. Actually, everyone will be testing in the afternoon. Yeah. So if you want to come to the Class Connect, you can on Wednesday. That's a good point. Obviously, like I said, I'm going to understand if you want to take the day off, you are free to do that, and it will be recorded. Because I know in some of your other classes you might not have the 2 flex days. You might only have 1, and so you might need to get in some other work that morning. So if you feel that you don't have time to come to Class Connect Wednesday, I understand. I will miss you. I'll miss you guys all for a week and a day. So come Wednesday if you can, but if not, it will be recorded, so you can go back and catch that recording, okay? Alrighty, let's get going. So the objectives, what we're going to do today, we're going to cover 3.09 and 3.10. And then my goal on Wednesday is to do 3.11 and 3.12. That way everything for Unit 3 is covered, even though I won't be seeing you next week. I already have a recording for the test. And that way you'll be ready to go. Okay, we've talked about all of Unit 3 up to that point. Okay, so for 3.09 we're going to talk about continuing the idea of triangle similarity. We're going to talk about 2 different theorems in 3.09 and 3.10. Actually 3.10 we're going to talk about a couple theorems, and 3.9 is 1, so a total of 3, but using the similarity idea to where you can make some proportions and relationships between sides and solve for x. Okay. I know, Tristan, you told me last time. Do you remember me telling you that? That makes me sad. Well, and I understand the reasoning behind it. I just, if you guys are, if you like COVA, we are a public school, and by state law we have to do state testing, whether you like it or not. So if you like COVA, I would appreciate if you just go, because Tristan, you do awesome. Yeah, no, it's actually math and English. Yep, we have to test, and then the next test you'll have an April CMAS. You have to do social studies and science. Yep, just 2 half days. You actually can't. By state law, you can't, Michaela. So, and what it does is it just hurts the school, because it's like we're taking a 0 on that average. So, yeah. So if you come support COVA, if nothing else, I know it's. I understand both sides. I really do. But if you're making the choice to be in COVA, which is a public school, then just realize that that's something you got to do. Okay. So here's the first theorem for 3.09. It's called the proportional altitudes theorem. Okay, so first let's remember what an altitude is. What's another word for altitude of a triangle? What's another word we use for that? Good, Ben. Height. Yes, good, Tristan. So if you look at the 2 triangles here, the red dotted line, that represents the height. So remember, the height is from the top vertex of the triangle to the other side. You want to look for the right angle. Okay? So here's the theorem. It says, okay, first of all, you have to know that the 2 triangles are similar. So in this case, they're telling us the 2 triangles are similar. Remember, that's the symbol for it. And it's telling us BD and FH are altitudes. It wouldn't have to tell us that. We could look at the picture and conclude that. Okay? It's saying, okay, if you know those 2 things, then here's a proportion that you can make. So the first proportion, or the first, well, this is really just the fraction, the whole thing to put together is the proportion. So the first fraction is just the altitudes. So we have BD, the height or the altitude of that triangle, over FH, which is the height of that triangle. It's equal to AB over EF. Okay. Now, notice here in the theorem it says their corresponding altitudes have the same ratio as their corresponding sides. So we could add another proportion here, or another, yes, exactly, Will. That's great. That's exactly what the point I was trying to make. We could add here that we could also say it's equal to BC over G. Okay, so the example that they wrote were sides A, B, and EF, the left sides, but it is also true for the right sides. Okay, and yes, well, it is also true for the bottom sides, AC and EG. So I could also say that these ratios, all these ratios would be equal, AC over EG. Okay, so this is the only one, basically this is the altitude or the height. So you make a fraction out of the heights of the triangles, and then all of the other fractions here are just the matching sides, the corresponding sides. Okay? So this is the proportional altitudes theorem. Now you will have a question on the quiz that asks, okay, here's a ratio that's true. How did the kid know that that was true? So because of the, in the proportion, you'll see that it'll have the altitudes. And so that should be your clue, because this is called the proportional altitudes theorem. You'll be able to say, oh, here's the ratio of the altitudes, so that has to be because of the proportional altitudes theorem. Okay, so do pay attention to the name of that. Again, the criteria is you have to know the triangles are similar. As long as you know that the ratio of the altitudes is the same as the ratio of any of the sides. Okay? All right, so let's apply it here. It says, by the proportional altitudes theorem, which of the following is true? Okay, so take a look, and again, you guys hopefully are getting used to this. With similarity, it's really just a matching game. So let's take a look at, and you guys have polling tools, so go ahead and put it in your polling tool once you find the answer. So we have CB over GE. Okay, that doesn't look good, right? Because we have CB, which is the left side of that triangle. GE is the bottom side of that triangle. Those don't match up, so we'll cross out A. BD, FH. Is that a good match? Give me a smiley face if the first part of answer choice B looks good so far. Yes. Okay, just this part looks good. Now we got to check this. So let's see if this matches up. CB, which is the left side of the top triangle, EF, it's the right side. Nope, doesn't match, right? Okay, so I'm seeing lots of answer choice C's in there. Let's check. Let's see if you guys are correct. BD and FH, yep, we already talked that looks good because those are the altitudes, or the heights of each triangle. Okay, again, that's where the name of the theorem comes from, the proportional altitudes theorem. You make a fraction of the altitudes. That ratio is equal to the matching sides. So we have to make sure over here that the sides match up. CB is the left side, GF is the left side. Yeah, looks good. Okay, so yep, C would be correct here. Any questions on that one? I'm going to move quickly today to make sure we get through everything, so I'm going to keep you on your toes. All right, here's another type question you might run into. At a certain time of day, a child whose height is 40 inches, okay, so now we didn't actually draw the child here. We are representing the child by a stick. Okay, well, here, let's draw a stick figure. Here's his head. Here's his feet and his arms. Okay, there's the child. He is 40 inches. Okay, and he casts a shadow. Where is your shadow? Students, here, we'll say it's a girl. Here we go. How about some curly, long hair and a skirt. There we go. Okay. Yeah, I'm not a very good artist, but anyway, there's my stick figure. Yeah, I would agree, Gabby. We'll give her a break. She's, only 40 inches. She's maybe like, probably like 3 years old. Hey, by the way, 40 inches, if you have a little brother or sister or a nephew or niece or something, that's the height, that's a good height minimum to take them to Disneyland. They have to be 40 inches tall to ride on a lot of the rides. So this is the little kid, okay? 3 years. That's how I know, because my son was 3 when we went to Disneyland, and he was just 40 inches tall. So, All right, so think about where the shadow is. So where is the shadow for this girl that needs fashion advice? Let me give you guys whiteboard privilege. Point to where the shadow would be. Show me what side of the triangle would represent the shadow. Good. Good. The bottom line. Okay, because I get a lot of students that want to say, this is her shadow. No, think about, okay, when you look at your shadow, where is it? It's on the ground. So from N to L. Okay, very good. Thank you. Thank you. Yes, so right here would be her shadow. Okay? So it's saying cast a shadow that is 26 inches long. That's why they have the 26 down here between N and L. Okay? The child's father casts a shadow that is 44.2 inches long. Okay, here's 44.2 inches. Where do you think the father is supposed to be? What side of the triangle is he represented by? JL is his shadow. Where is he actually standing though? Yeah, JK. All right, so I got to attempt to draw another stick figure. Okay, let's see. Here's the father. Here, he has a tie on, okay? And okay, that looks awful. But anyway, there's his clothes. You guys are going to have to give me some drawing. There we go, a cape. Ah, I like that. Oh my, I don't know if I can do that, Ben. There we go. Yeah, he's in his pajamas. It's Saturday morning. He went out to get the newspaper. Okay. Anyway, all right, so we're going to solve for x to determine the father's height in inches. Okay, so just regarding my terrible drawing, okay, let's go back and remember what the theorem says, okay? So we have the proportional altitudes theorem. So what kind of triangles do we have here? We really have two triangles, right? And a lot of times, we'll start running into this type of picture quite often here from now until the end of the year, where you have a large right triangle and then a smaller right triangle inside of it. My advice, if you are getting confused, draw them out separately. A lot of times that will help. We'll run into this type of picture a lot when we get to trigonometry. And so if you draw the triangles out separately, that will help you quite a bit. So yes, we have two right triangles. Okay, and I'm going to draw them out separately. This is the large one, KJL. And we know that the distance from K to L is 44.2. The x value is over here. That's the father's height. Then the small triangle is triangle MNL, where the child is at. We said it's a girl, and she's 40 inches tall. Her shadow is 26 inches. Why am I allowed to use the proportional altitudes theorem? Put it in polling, Gabby. So if you get the answer, put it over here. Select your answer. Okay? So I think you guys could probably, I think you're figuring out how to solve this, but let's think about why. Are you allowed to use the proportional altitudes theorem here? Yep. Why, Ben? What were the two things that you had to have to be able to use this theorem? Yeah, exactly. Well, it is a version of the side-splitting theorem. You're right. You're right, and it's an extension of that. And they'll go through the proof of it in the lessons if you're interested. Okay. Okay. True. Now let's take it back a step, not go quite so deep. So hang on just a second. Let me go back here. There were two criteria. It says the two triangles are similar. So that's the first thing that we check. We have to see, are these two triangles similar? Okay, they are. How do I know? I'll give you a hint. I can show it by angle. Remember, that was one of the theorems that we can use to show triangles are similar. What are the two angles that are the same in triangle KJL and triangle MNL? Good. Triangle. Okay, so angle J is the same as angle what? Angle J is congruent to, yes, angle N. They're both right angles, right? What's the other one? Angle L has to be congruent to angle L. Yeah, exactly. Okay, now the reason is, it's not marked here when I drew them out separately, but look at the picture. They're overlapping, okay? In the small triangle where the child is, angle L is there. And in the large triangle, angle L has to be the same, right? It's really the same, it's just that the triangles are overlapping, okay? And so I can show that the two triangles are similar by angle. Okay, remember that. All right, and so we've shown that the two triangles are similar, and so it says, okay, well then yeah, I can use the proportional altitudes theorem, and I can make a proportion with the altitude. So where are the altitudes? We have right triangles. Where are the altitudes? Which sides represent the altitudes? Okay, good. JK is the altitude of the large triangle. Yep. There we go. MN is the altitude of the small triangle. Yep. So we want to definitely make sure when we solve this that we involve the altitudes in our proportion, right? So we want to do KJ over MN, right? Those are the altitudes of the triangles. And then I can do any other pairs of sides. I don't really probably want to do KL and ML because I don't know anything about them and I don't need to know them. So I want to do JL over NL because I know what JL is, I know what NL is, and so that's going to help me solve this. Okay? And again, you want to match from top to bottom. We're matching altitudes. These are both altitudes. These are both sides. And I'm matching across. These both come from the large triangle. These both come from the small triangle. Okay? What are you going to do from here? How do I finish this out? Okay, good. Substitute. So I'm going to have x over 40 equals 44.2 over 26. You math it. That is true, Tristan, except that's a little vague. Okay, good, Gabby. Plug in the numbers. Then how do you math it from here? Tell me more specifically. What would I do? We've been doing this a lot in Unit 3, so I think you guys have it down by now. Yeah, cross multiply, solve for x, okay? Yes. Good. Okay, so you should get, I think it's D on this one. Did you guys get D? I forgot to clear out the answers from last time. So you would do, yeah. Yes, awesome, Delia. Good. Okay, D. Very nice. Very nice. Good. All right, moving on to 3.10. We're going to talk about the proportional angle bisectors theorem. So here's what it says. It says, first of all, you have to know the triangles are similar, okay? Or if they don't tell you that they're similar, if you can prove that they're similar, then that would work as well. But you have to either be told that they are or be able to prove that they are similar. Then their corresponding angle bisectors have the same ratio as their corresponding sides. So let's go back and review what's an angle bisector. It's a line that cuts an angle in half. So MQ, for example, it's kind of like, pretend this is an arrow. It goes, and it cuts this angle into two pieces. Okay? JK is an angle bisector, cuts this angle into two equal pieces. Okay? Now it tells us here that the two triangles are similar. We, from the picture, would be able to determine that as well because we can see angle N and K are the same, angle M and J are the same, so we could conclude that they are similar by angle. Okay? Yeah, I know. That's why I said second semester gets hard because we have to go back to first semester and still bring all that with us. So yeah, there's a lot going on in your brain right now that you have to remember. By the time we get to March in geometry, there's a lot of stuff. Okay, so here's what the theorem says. It says JH and MQ. What are these? Look at the picture. What's your backup brain supposed to remember? What's the name of these? JH and MQ? I agree. Well, that would be super nice. Just wait till you guys get old enough and you have kids, then you're going to need a backup brain. Because my brain is half of what it used to be. Not the altitudes. That was when we were doing the proportional altitudes theorem. I was going to say, really, Devin? I mean, it is possible. Yes, okay, there you go, Ben. What kind of a bisector? Angle bisector, yes. Okay, that's why it's called the angle bisectors theorem. So just like a second ago when we were talking about the altitudes, proportional altitudes theorem, now we're talking about the proportional angle bisectors theorem. Okay, so you're going to look, remember that this is the arrow that cuts angle M into 2. JH cuts angle J into 2. So we want to start our proportion with those angle bisectors. And then over here, we can have any corresponding sides. Okay, so they happen to do JK and MN. What other ratios could we add to that besides JK and MN? What else? What other sides would be equivalent? What other ratios would be the same there? Okay, K, L, and NP. Yep, that would work. What else? There's one more. Good. J, L, and MP. Okay, so you can use any two of these. You wouldn't need all four of them, but if you knew information about the angle bisectors and you knew these two sides, then put those together in a proportion, okay? Okay, anybody want to try this one on the board for me? Let's see if we can apply it. All right, we'll go for it. Tell you, no, I don't. Okay, well, at least you know. I know. I think today's especially hard because we had the time change this weekend. And what would be so bad about that, Gabby? You would not be the first person that would not know something in math, right? Raise your hand if you have gotten every single math question right in your whole entire math career. Devin, put your hand down. I know that's not true. Hey, I'm not going to raise my hand either because that is not true. Nobody has, right? Exactly. Not even Einstein did that, I guarantee you. That's what we're here for. We are learning, and it's okay if we mess up because you know what? Most of the time we learn, like the whole class would learn something from that anyway. Okay, good point, Will. Yes, you're not saying that you know everything. You just already had it up. Yes. Awesome, Ben. And that's true. Definitely, you know, up to a certain point, some of us might have gotten it right, but eventually, if you keep going, you know, there might be questions that, like theorems that haven't even been proven yet, right? Maybe some of you guys will go on to do that, but you're probably not going to get it right the first time. You might end up proving it eventually, but even if we are super great at math, there's something that we run into eventually that we're not going to get right. Well, you know what? We are all friendly in here. No one's going to make fun of you. And even if you get it wrong, when you get it right at the end, we are going to applaud you. So you guys should go for it. Well, Delia, you're a good sport, but we're still not going to do that. Awesome, Tabitha. Yeah, when you're in park testing, I forgot. You're not going to be here Wednesday. All right, well, the next time you're here, I'm not going to forget. I'm going to make you step out of your comfort zone. Okay, Will is off to a great start here. So he said, okay, I remembered I'm doing angle bisectors theorem, so I'm going to start out by making a ratio or a fraction with my bisectors. So he put RT over EB, because remember, these are the angle bisectors. They're cutting angle E in half here and angle R in half up here. Okay, and then he took RQ over ED because those are the other two sides we have information about. Okay, and then he is cross multiplying. Cool, cool, which is fine. Okay, so I love, Will is always showing us something new and unique, which is great. So you could definitely cross multiply here. Will chose to actually take 26 and divide it by 40 to get the fraction of 0.65, and then he's multiplying by 24. Okay. Nice. So that works. And that might be a good thing for some of you to try, because you probably would tend to make less of a mistake than cross multiplying. If you do cross multiply after this step right here, just be really careful to put parentheses around the 2x minus 4. Remember how we talked about that last time. Okay? Okay, good. Some of you got answer A already, and it looks like that's what Will is going to get, which is perfect. Yep. Excellent. Thank you, Will. Give Will a round of applause for jumping on the whiteboard and doing that. Nice.